Assalamu alaikum dear viewers, Shoaib Dayo is here, and today's our lecture is totally related to the laws of the electromagnetic inductions. So before explaining these laws of the Faraday's and even the Lenz's law of electromagnetic inductions, we have to know what is the induction process. Induction process is the process of the production of EMF within the conductors, or the generation of the EMF in the conductors, or the coil that is called as the induction process. So as you can see from the board, the definition which I have written on the board, that the phenomena of the production of the EMF and hence current in a conductor or the coil when magnetic flux linking that conductor or coil changes, that will be called as the electromagnetic induction. So take an example of this coil and the permanent magnet for to explain the electromagnetic induction process. That this is the coil which has the several number of the turns wound on a core of any ferromagnetic material. And if we are wounding some turns of the wire on a magnetic material, so it will be called as a coil or the solenoid. And here the galvanometer is used for measuring the current which is induced in the coil. If the current is to be induced, that can be easily measured with the help of that galvanometer. So this is the permanent magnet, and if we are closing the permanent magnet to that coil, what happens? The galvanometer reads the amount of the current which is induced in the coil in one direction. So if we are moving away this permanent magnet from this coil, then it will give us the reading in the opposite direction. So means if we are increasing, means close that magnet to that coil or away that coil, the galvanometer will give us the reading in one direction and in the opposite direction. Now, if we are going to take an example of that, your permanent magnet within the coil, the production of the EMF can be induced in a coil. For these three essential things we have to keep in our mind, that the conductors, the magnetic field as a coupling medium, and your motion of the conductor is the necessary requirement for the production of the EMF in the magnetic your electrical machines. Okay, so this one is the total concept regarding the electromagnetic induction process. And if we are stopping the movement of the permanent magnet in this coil, what happened? The galvanometer reading will be reaches up to that 0, because the main thing for the production of the EMF is that the magnetic flux linking with that conductor, but the conductor position should be the changed one. This will be called as the electromagnetic induction process if the magnetic flux is linking with that conductor and the conductor polarity should be the changing one. So that's why the EMF will be induced. So coming towards the Faraday's law of electromagnetic induction. He was the scientist, English scientist. He gave the law of the electromagnetic induction in 1831. Okay. Now, if we have to explain this law, the first this law can be divided into the two parts. First law is that when magnetic flux linking a conductor or coil is changes, an EMF is induced. An EMF is induced in it. If this is a like conductor and flux, or for example this conductor is to be excited with any kind of the field, and if there is a motion of the conductor is to be takes place with the help of any kind of the external source of the framework, then the magnetic flux which is already excited and which is already present in the coil, and already the motion of the conductor is to be takes place from that external framework. What happened? These three things are to be combined together, means the conductor, the magnetic field which is a coupling medium over here, and the motion of the conductor which is to be rotated with the help of any kind of the external prime wire, what happened? Your EMF will be induced in the coil. So these are the main three essential conditions. Now second law is that the magnitude of the induced EMF is directly proportional to the rate of change of the flux with respect to the time. Means already the EMF is induced, but its rate of change of flux with respect to the time means it represents that the amount of the flux can be varied. Okay, if the rate of change of the flux are the maximum within the conductor or the coil, EMF will be maximum we will obtain at the output of any conductor or the coil. So here I have written an expression for calculating the EMF induced in the conductor, so that E is equal to N d phi over dt. Okay, here if the coil has the n number of the turns, okay, phi 1 is to be changes from that initial flux within producing the coil, and F phi 2 is the final flux which is produced in the coil, and change of the flux will be of that difference of that 2 phi 2 minus phi 1. So that will be the change. If that will be the change produced in the change of the flux produced in that coil, obviously the EMF will be induced, because changing of the flux with respect to the time may cause the production of the EMF in the coil. So this is the main concept regarding the Faraday's law of the electromagnetic induction. Here from this expression, if we are increasing the number of the turns of the coil, EMF will be more induced, and if we are changing the flux with respect to the time is maximum, here means rate of change of flux with respect to the time is maximum, again EMF is induced in the coil will be maximum. So if we are putting the minus sign in this expression, this minus sign shows the Lenz's law. The Lenz's law is that the direction of the induced EMF is opposes that cause which is given to producers. Take the example of the motors, that in the electrical motor, the electrical energy is converted into the mechanical energy. For example, take the example of the DC motor. So before that, we have to explain the Lenz's law. So what Lenz's law shows, describes us or explains us. Emil Lenz, he was the German scientist. He gave the law for the measure the direction of the induced EMF. Faraday's law gave us the law regarding the production of the EMF, and here this Lenz scientist gave us the direction of that induced EMF in the conductor. The induced current will flow in such a direction so as to oppose the cause which is given to rise it or produce it. For example, here take an example of the coil magnet. Each and every magnet has the two poles, north pole and the south pole, and the coil has the number of the turns of the wire moved on the magnetic material, and the galvanometer is used for measurement of the current in the coil which is induced. Now if we are taking the example of the DC motor here, the DC motor has the two windings, the armature winding and the field winding. Okay, the field winding is excited from the DC supply to produce the magnetism effect. Okay, and the armature winding, the DC external electrical energy is going to be supplied to that your armature winding. Okay, then what happened? The induced currents are produced. The induced currents are produced within the armature conductors, within the rotating part of the DC motor. Now that induced currents which are produced in the rotor totally opposite to that applied voltage which is given to that armature terminals of the DC motor. So this is called as Lenz's law, means the direction of the induced EMF means within your rotor side is opposite to that applied voltage that you are giving to that motor. So this is called the Lenz's law, means you are supplying the applied voltage, you are connecting the electrical motor with the supply voltage, the induced currents are produced due to the applied voltage, and that voltage which is produced in the armature or induced currents or EMF which is produced in the armature or rotating part of the motor is totally opposite to that applied voltage. So this is the Lenz's law. Okay, so here N pole of the magnet is approaching to that coil which has the several number of the turns and n pole of the magnet to move towards the coil and magnetic flux is linking with the coil is increasing. Means if the magnetism is strengthened one over here, then obviously the magnetic flux will be greater, magnetic field will be greater, and hence the EMF which is produced in the coil or the number of the turns of the wire within the conductors will be maximum one. Okay, so therefore an EMF and hence currents are induced in a coil according to the Faraday's law of electromagnetic induction. Means in this diagram or in the Lenz Law circuit, you are applying the supply or connecting the any machine with the supply voltage and currents are being induced or EMF is induced in the rotor side or in the conductors. So this is the production of the EMF. Okay, production of the EMF within the conductor is due to the Faraday's law of electromagnetic induction. But here in this case the cause of the induced current is increasing by increasing in the magnetic flux, okay, linking the coil. Okay, so here induced current will set up the magnetic flux that opposes the increase of the flux which is through linking that coil. Means increase the supply voltage, increase will be the magnetic flux within the conductor. That increase in the magnetic flux within the conductor will opposite to that, will give us the opposition to that applied voltage. So this is called as the Lenz law. Means the direction of that induced EMF in the within the conductor, production of that induced EMF within the conductor whose direction is that such that opposes the cause which is given to produces. So this was the Lenz law. The direction of the induced EMF can also be determined with another principle which is called as the Fleming right hand rules. In the right hand rules, stretch out the forefinger, middle finger and the thumb. Thumb will show the direction of the magnetic direction of the motion of the conductor. Forefinger show the direction of the magnetic field, okay, and this middle finger shows the direction of the induced currents or the induced generated currents within the conductor. So this is the Fleming right hand rules, okay, right hand rule. So this was the today's lecture regarding the electromagnetic induction process. Faraday's law we have explained, the Lenz's law we have explained, and I hope that you have understand the today's lecture regarding the laws of the electromagnetic induction. And at the last, please don't forget to subscribe my YouTube channel Shoaib Dayo for more interesting videos related to the electrical engineering area, and your subscription motivates me to make more contents related to this electrical engineering. Thank you.